All right. Hello, everyone. This is Denver Droids. My name is Eric Garcia. I'm the host, and we have an amazing presentation today. Ditto, how to do peer-to-peer syncing for applications. So during the presentation today, we're going to have Ben Chatelain go through um, what is Ditto and how to leverage it to sync your data on the cloud. Um, but before we get that, I would like to mention Denver Droids. We are a group that is passionate about how to empower uh, the mobile applications using technology, and we cover many topics from all the way from the basics to um, even more specialized stuff, just like tonight with peer-to-peer syncing. Um, Stay posted. We have the Meetup group page where you can stay up to date on what are we going to be showcasing. We host every uh, third Tuesday of the month. Let's go ahead, Ben, please go ahead and introduce yourself. I know we're all super excited to learn about Ditto, so please go ahead and show us how can we use and leverage the power of uh, syncing offline.
All right. Thank you, Eric. Um, and all right, so I guess starting with who I am. I'm Ben Chatelain, known as Fat Flat across the internet, and I'm a senior product engineer at Ditto. I've actually only worked at Ditto 2 months now, so I'm still new to this whole syncing thing. But well, new to the Ditto way of syncing thing. I've been a fan of Realm and MongoDB Realm syncing approaches for years because it's just so nice to let a framework take care of REST for you and just get me the data. I don't care where it is or where it's coming from. I want to work with data and show it as a mobile developer. So I've been very passionate about this space, trying to use it in apps, and I ended up joining a company that does it. But Ditto is unique, and as we'll get into, in the fact that it enables true peer-to-peer syncing. A little bit more about myself. I've given several talks in recent years, mostly virtual, pre-recorded due to COVID, like talking about MongoDB Realm. Also, I talked about Gradle at 360 AndDev last year. I don't know if AndDev's going to happen this year. So I'm very active on open source, often working on iOS and Mac related things. But one of the main reasons I ended up taking this job at Ditto is because we're supporting all platforms, like all major platforms. So iOS, Android, web, and we've got some new stuff coming up, like for the Xamarin framework, and we're eyeing Flutter and React Native in the near future. So yeah, I'm also very interested in the NDK layer stuff because that's key to how things work at Ditto. And our core is Rust, which I'll get into towards the end of the talk. But we're actually using FFI as our C interface. So we have a cross-platform core, and then I work on the native bindings. So the Android SDK, the iOS SDK, and future SDKs. So without further ado, let's get into what Ditto is and why I think it is absolutely amazing. All right, I'm going to load tech it, and we're going to do it this way. Okay, Ditto. So this is a framework, a library you would add to your app to enable this syncing. And it takes care of two architecture layers for you. The storage, so your persistence layer, and the network layer. You can use Ditto to shuttle data in and out of your app automatically so that you don't have to write REST calls or deal with, parsing whatever formats coming from the server and putting it in a database. It comes out of a database into your application, and you put it in the database and let it do its magic. So this is a sales deck, but it's very technical, and we're going to focus on most of the technical parts. But if you guys have any questions, feel free to stop me, and we can focus on that to get your questions answered. So it's a lot of apps, all of our apps are talking to the cloud, and it's very easy to forget how fragile the system is. Like, we'll remember when AWS goes down, or when you get out of range of your connection and you have that bad experience, and then we forget about it because Wi-Fi is ubiquitous, internet's ubiquitous, and it's only at those edge cases where this really shows up. And so Ditto is actually working with a bunch of big companies that operate in this edge space, and Ditto is a lifesaver for them because they're dealing with this every day. So this might not be like a critical framework for your app, but I encourage you to think about, what if there was a world war and something happened and we lost X, Y, and Z that I count on. Like, having the ability for devices to talk to each other just is so freeing in the fact that you can still do amazing things. So keep that in mind, and that's what this framework is designed for. It may not be perfect for the app you're working on today, but there are a lot of cases where this is just a lifesaver. So the key thing about Ditto is you can put this SDK in your app, and apps can sync without internet. So you don't have to have a cloud connection. You can even lose connection between the devices, and they can be adding, deleting data, and when they come back online or they reestablish that peer-to-peer connection, they can sync it up, and all the state of your application can catch right back up. And it's quite amazing how well this works. So our full architecture, we have two key pieces: the big peer, which is the cloud worker, and the small peer, which is what you'd be running in your Android app. And this is cross-platform, so it can sync between OSs. There's some caveats that we'll get into with cross-platform stuff, but in general, the data can flow across platforms. And sort of the main difference between the big peer and the small peer is small peers use selfish replication. They only keep what they want. And big peers are sort of like your online backup. They just keep everything. So it's kind of baked in that you'd use cloud as, I'm going to store everything there and maybe do backups. And on my phone, I might be a little more selfish and not keep everything. And also that makes for faster transfers if we're not trying to send the entire world. But once these network connections are established via Bluetooth or LAN, what's actually constructed under the hoods is a mesh network, and data can be shuttled across this network even if two nodes do not have direct connections to each other. So a laptop over here can go across a mesh to a device that has internet access when it alone doesn't have access. That syncs up to the cloud in the big peer, and then some device over here on this other mesh that's disconnected can send data all the way over to this device. So this is the true magic, where you can kind of have your mixed scenarios where somebody has internet access, somebody doesn't. And as long as you can establish a chain all the way across those, you can still get data from one end to the other. So focusing on some use cases very quickly, flights are notorious. You're up in the sky. Sometimes the Wi-Fi isn't working. Even if it is working, it might be really slow. So just being able to order food, or for the crew of the flight to be able to communicate back and forth with each other without having to run through the plane, or you place an order for your drink order and they're out of that. You could find out immediately, perhaps because the inventory is already up to date on your device and you can't add it to a cart. Also maintenance, like in industrial scenarios where things are spread out, you might not have good connections. This is notorious where somebody might work with a local database and then it's a huge pain to get that all sunk back up. But if you can hop from device to device and somebody has internet access, you can get that cloud data down to the people who are working, and then they don't need immediate access to the internet because they have that checklist that's relatively fresh. So here's that passenger meal order use case, which there's a lot of airlines that are very interested in this. Chat, we actually have a Ditto chat app that's in the Google Play Store that you can download for free, and see how it works. So this is very cool. Like somebody was actually going to build this for Ukraine. They were looking for iOS developers that know Bluetooth and stuff. And I'm like, just download the Ditto chat app and try it out. Literally, it does that all for you. You're going to be spending forever. By the way, we have an extremely long blog post that should be a book about how to implement core Bluetooth on iOS. And like, I encourage you to not do that because it is so hard and such a pain, and our framework actually already does that for you. So here's another use case, point of sale ordering. Rather than waiting in line, you could be entering your order straight to the local kiosk. And like you could do right now with DoorDash or other apps, that goes through up to the cloud. If you have these, hyper local scenarios, sometimes syncing across the local network would be faster to get it to the front of the line. Especially if like there was a spotty internet connection. Maybe this is a food truck who doesn't know if they're going to have good connection. Another use case is electronic flight bags, where one pilot might need to transfer a lot of data, like maps data or stuff from device to device, and that can take a long time if you're sending it through longer connections. All right, let me skip past some of these. Well, this one's a little similar to the graph we saw earlier, where you can have, ground crews, say, all connected to each other through either a mesh network and then through the cloud to an airplane, where you really only need, instead of everybody on the plane having to download the same data, it actually only needs to download once, and then it can be shared across those devices through peer-to-peer syncing. So the peer-to-peer syncing also benefits like a cache, where if your app on multiple devices is looking for the same data, you don't have to go across a very, either fragile or low bandwidth connection to get that data, because you can get it from your peers. So there's additional benefits, not just this purely offline scenario. Okay, so let's talk about like the lowest layer, the network. So in these graphs, we have various colors, and I'm going to get into what these mean. But in general, you put data into Ditto, the data gets broken up, sent in packets across whatever transports are available, and then it's reconstructed automatically on the other side. So one packet of data might actually go across multiple transports, like Wi-Fi and Bluetooth. And we'll look a little closer at that. So the colors, and I apologize for anybody who's colorblind, but blue is Bluetooth low energy. And note that we use low energy Bluetooth, not Bluetooth classic. So there's none of those standard pairing dialogues. You do have to grant permission to Bluetooth, or the user does, to be able to use this. But it just works like in the background, which is amazing, as long as they accept that permission. And we have two Wi-Fi modes. Green is like we're both on the local area network. So a broadcast on the local area network can find other Ditto instances. And the pink here is peer-to-peer Wi-Fi. So this will be AWDL on iOS or Wi-Fi Direct on Android. We are actually looking into Wi-Fi Aware, as it's been getting more adoption, but we don't have support for that yet. And orange is like USB. If this is kind of a limited use case, but Ditto does support just plugging in and syncing. So if you had a desktop app and a mobile app and you just wanted to sync a lot of data, that option is available. But it kind of depends on your use case. So LAN Wi-Fi, you can have many devices. It's very high bandwidth, no internet really needed to be able to sync data. And this is your typical Wi-Fi scenario. So things work really good if both the devices or all the devices in your mesh are on the local area network. So it's the fastest backbone. You can have multiple access points, but the other transports that we'll get into cover a lot more of the edge cases. So peer-to-peer Wi-Fi, this can happen in addition to the local Wi-Fi, where two devices can set up an ad hoc Wi-Fi network with each other while they're also connected to the LAN. This is also very high bandwidth, but this type of peer-to-peer Wi-Fi is not cross-platform between iOS and Android. So you can have all your Android devices talking peer-to-peer Wi-Fi, but you can't pair an iOS and Android device because they have different types of peer-to-peer Wi-Fi, but they can still talk over Bluetooth. Now the limit for peer-to-peer Wi-Fi is about 25 meters. It's high bandwidth, but short range. And yeah, here's that not cross-platform bit. Just has to do with how each platform implemented their peer-to-peer Wi-Fi stuff. Now, Bluetooth is the real king when it comes to distance, because amazingly, Bluetooth energy, we've tested and connections can work up to 425 feet or 130 meters. That's pretty low bandwidth, especially at that range. And Ditto actually will adjust the MTU size for how much data it's sending based on the status of the connection. So you bring those devices closer, they're going to have higher bandwidth, they're going to send bigger packets at a time, but they get further away. You're still going to have a connection, but you might only have like the kind of performance you would need for chat. Like if you're trying to send a whole image or try and maintain a video stream, things would be really shoddy at these long distances. But this is the one that will maintain a tether at the most extreme edges of what Ditto supports. And it works really good on planes, because planes are like a big giant metal tube, and so signals bounce around and stay inside, and it could go all the way through these big giant planes, which is why airlines are so interested in Ditto. It just works amazingly well. Okay, so the bus API, this is the lowest level API in the Ditto stack that you may or may not be interested in but this is if you wanted to just send raw data across the network, take direct advantage of the mesh network. So how this works is you use our presence API to discover other peer devices that are on the mesh, and you send bytes directly to that peer. This is really ideal for, like, say, a video call or a voice call, sending a raw stream of stuff. You can send files, and we have some different reliability modes depending on whether you're just sending video that you don't care if there's a few drop frames, or if you're sending a file and you really care, you want that file to be complete. So there's a couple different choices there. And it can broadcast the same thing to a bunch of peers. So you could be doing a live stream concert with just peer-to-peer stuff if you really wanted to. So here's an example of the unreliable connection if you're just trying to send a video feed or something from one device to another, where it's okay if things are out of order or duplicated. Let's see. Unreliable sequence is one step up in reliability, where it doesn't allow them to be out of sequence, but does allow for drop packets. And then reliable would be the mode if you're trying to send a file and you don't want that all garbled up on the other end. So that's the lowest level. It's fairly new. We call it experimental because we're still working out some of the kinks, like with being able to identify the peers on the other end. But it is available if you want to experiment with, trying out. I'm going to do Denver Droids app, and we're going to do peer-to-peer streaming of this video. So the store API is probably the main area of focus, because it takes advantage of the most stuff in Ditto. So that mesh layer is kind of the foundation, And the store has some really cool stuff as well. So we saw this before, and let's see, nothing new, but okay. So when we're talking about the database, it's a document database. Everything is pretty much JSON. So you're interacting with maps on Android and working with keys and values and that sort of thing. So each different document will be stored in a collection. Works a lot like MongoDB, where you can just create a collection on the fly just by inserting a document into it. So I can have cars and planes and products and stuff, anything I want in there. So each document is going to have an ID. If you don't supply a custom ID, we'll generate one. I think it's like a UUID. So you could have your own scheme for generating IDs, or you can just let Ditto create it for you. But every document has to have an ID, which is why we create that. So when it comes to syncing through the store, the syncing deals with these collections of documents. And as we'll see when we get to the live queries, what gets synced to you through the store depends on what you're waiting for. So it's kind of like a query gets sent out to every device, and anything matching that query on all the other devices gets sent to you. So supported data types, your standard, kind of primitives, if you will, strings, numbers, Booleans. You can have arrays inside here, and you can have inner dictionaries or submaps, and you can have small amounts of binary. And one thing that's really cool about Ditto is it supports attachments. So say you do have a big file and you don't want to just deal with a URL because this is a purely offline app, so there's no web URL to go fetch it. You can actually put that in the database, but say I'm an attachment so that it can sync the document data first and deal with downloading the attachment later. The attachments are actually downloaded using rsync, so it can continue the file and it can actually continue from another peer. At the moment, it can't actually multiplex that file from multiple peers that might have it, but say you were sharing an image, it's best to use an attachment for that so that any other more relevant changes to the data model would show up immediately, and you could wait for that image to load in. And Ditto handles that for you, so you don't have to use a separate library for it. Okay, so here's what the API looks like. So very simple example, just creating a cars collection and inserting 3 cars. Our API, we actually used to have both insert and update. We've recently combined those to just upsert. So if you upsert something with an ID that doesn't exist, that document will get created. If that ID does exist, this would actually be an update, and it would change the name to Honda Accord and the color to red. So it'll take care of all of that. And there actually are some strategies you can specify where if you don't want it to overwrite stuff, but the default strategy is to kind of merge that data together. So here's an example of searching for documents, and apologies, but what comes back in this one is actually a list of Ditto documents. So that at the bottom is searching by a specific ID. So you specify the ID, you're going to get 1 or 0 back. And this is kind of like a builder API where you call exec at the end to say, I'm done adding stuff to this query, because you could maybe add a sort to it and other things. And then exec is, yes, my query is compiled, go ahead and run it. This will return a car or null. But this example up here is find all cars that match this property, color equals red. We actually do have a find all, which doesn't take any parameters, that just says give me every car. So this is an immediately executed query. We're going to see an example of a live query in a minute where it's kind of like that cursor stays open and more cars get delivered to you later. So this is a more refined example of kind of doing a bulk update. Like I want to find all cars that are red, and then for each one of those, I actually want to do an update. So I want to change red to blue and mark them all as sold. You do it using this map like key value access. And here's an example of deleting all the red cars. We have two flavors of delete. One is remove, which is delete it, and that literally gets deleted from all the other devices once the sync happens. And the other is evict. Evict is different than delete because it doesn't delete it permanently if it's been synced. So if I say evict, that says I don't want it anymore. But if it's on any other devices, don't delete it. Just remove it from mine. So there's a couple different ways to kind of manage the data. Like, for example, if I was a flight attendant, I might have a whole history of orders from that flight, but when I sign off in the app, I might evict all that data from that flight, but it wouldn't delete it from the cloud or other people's devices. And this does remove the IDs of what it actually matched if you were interested in that. So live queries, this is where things get really interesting. So similar to the other APIs, you can specify a query and things to modify what data is coming back, but then you wire up Lambda to get executed every time something changes with your data set. And this is what triggers sync to send you stuff that matches this query. So I'm interested in cars that have high mileage because I'm looking for a used car. I'm going to set up this observer, and it's going to return to me a list of cars that match that. And the first delivery of this is going to be what's in my local database. And the event info here is going to give you more details on, like whether this was the first one or metadata like cars were deleted and stuff, and this is what you could use to update a recycler view. But it also delivers the car information as part of this. So while this is open and before it gets stopped, this query, this live query, will get synced to other devices. So if somebody is tweaking the mileage and pushes the mileage up past this level, once that gets into your threshold, that client will actually push it straight to your device. So there's a lot of optimizations in Ditto, knowing that I've talked to a peer that's interested in this data. When I see that peer, go ahead and push it to them so that you don't have to wait for like your client to fetch it again. But if you want to conserve battery and that sort of thing, you can call stop to stop sending that data. Or if you were doing a map search and the person changed their preferences on what they were looking for, you could stop the old one and start a new one. So this is what I was saying about like A is curious about this stuff. We're going to observe. B is going to send a bunch of documents over. And then C is not getting the documents that match that query because it didn't subscribe to anything. And then once C enables the same type of query, then those documents get sent over. If they're being added or modified to fall into that range, the clients that have that data would send it over. So it's really cool that under the covers, Ditto is taking care of pushing you the data that you care about. And it's all about setting up these live queries. And now how sync works, while it is documents that are being synced, when changes are applied, it is at the property level. So there won't be a conflict if you have two documents and someone modifies a different property on each side. So here we have somebody setting sold out to true, and here, I guess they set it down here. So it just syncs that one change across. And then when we have other properties being changed, like somebody changed this to Toyota and is sold as true, those are not going to conflict with each other. There are other systems where if you have an old copy of the document and you change one property, when that gets synced to another one, it's going to totally wipe out any changes that are there. Now, when you modify the same property, that is a conflict. And under the covers, Ditto uses timestamps to figure out who's going to win. But it's a long story, but we use something called hybrid logical clocks. So it's kind of a combination of your actual time, but an integer on that, so that your time can be sort of figured out how it's relative to the other device's time. And that's a much longer conversation about that, but there are ways to kind of game that if you were doing something that was like very transactional. So if there was money involved or some reward like winning a game, you might want to require like some server side thing to approve it. Like I was booking an Airbnb, I might want to set things into a pending state until a trusted peer could approve that. Um, so some of that gets into the data model that if I'm truly doing peer-to-peer, it's like, okay, somebody can lie. You might have to have a trusted person in that circle to validate that connection. But that's really only when you get down to the single property conflicts. And under the covers, Ditto deals with certificates for all the connections. So every mesh network connection from peer-to-peer is encrypted. Ditto will generate these certificates automatically for like an enterprise production scenario. If your company wanted to control the certificates, that's certainly available to you. It's a longer conversation around how to get that set up, but the short answer is everything's encrypted on the wire by default. If you want to control certificates, that's possible. And this gets into permissions, because you can set user permissions and that can be encoded in the certificate so that they can't be modified. But it is pretty complicated figuring that out. So I encourage you to play around with Ditto with, like, we call it the online playground mode, where everybody can write. That's the best way to like learn it, and then think about data model and permissions when you're looking at taking this live, and we can certainly help you with that. Because things like this, if somebody updates a car and they're not allowed to because the certificate says they don't have permission, that would be denied and not synced across the mesh. So there are ways to protect your data based on users' permission. Okay, I have a couple more slides I want to get to because I want to get to the undercover stuff. But if you guys do have questions about this, feel free to email me, hit me up on GitHub, or create an issue on our like sample app repo, which I'll post a link to. This is kind of a summary of that last right wins thing, where T is the timestamp, and this is very abstracted into who has the later timestamp. But in general, if the timestamp is after the other one, they're going to win. Let me skip ahead. Here's our architecture. Okay, so like I said at the beginning, I think it was before we started recording, that our core is cross-platform Rust. There's slight variations in what gets included for each platform. And then we use a CFFI layer to expose those functions for the different languages. And while this is kind of like the lowest level of tech as far as like bridging across these, it's the most compatible, and that's why we're using it. But I am interested in seeing some advancements like connecting directly into Rust. Like actually on Android and Java, there's a new Java SDK coming that I've split out of the Android SDK. Both of those use a tool called Swig, SWIG, which takes some C header files and will generate the matching Java objects for you. And that's the foundation for our Android and Java SDKs, so that they can call into the Rust functions. This gets a lot more complicated, like on the JavaScript side. It's actually quite a bit simpler on the Swift and Objective-C side, where we just use Objective-C to go across this. But this is one of the reasons why with a team of like 30 people, we can support just about every platform, because we have all the smarts behind this stuff in the core. And I didn't have details to share, but in the store, the magic of how it can figure out, like even when two devices are out of out of touch with each other and adding stuff to the database. CRDTs is the core technology that we're using. It stands for conflict-free replicated data types. And it's data with metadata to help preserve the intent of what that insert, update, or delete was. And then that metadata allows it to merge with any other changes on other devices. It's a pretty amazing area of research that's been going on, and we're one of the I don't know, first or biggest companies like really putting this to the test in real devices. And honestly, the people working with this love it. There's some big companies that just want to use it everywhere. So my main point is I'm excited about this tech, and I want to see what you guys can build with this. All right. I think that's it for the slides. I'm going to pause to see if we have any questions before I jump into a demo.
Hey, I want to go back to the previous slide real quick.
Yeah.
Yes, there we go. I'm kind of curious about your FFI layer. Like, for those who don't know, it's called like foreign function interface. It's something that Rust has. And I linked in the chat section something about like from the Android developer docs, as far as like the first class support going on with Rust and Android. And I guess I'm just kind of curious what the differences are. This probably is a bit in the weeds and might not be able to answer this question, but I was using something called Uni FFI, and now I'm considering some other things. But your C layer that you're going through is something that I'm interested in to see how other people are doing it. And then there's also a company called Mersive here in Denver who hosts the Rust Meetup, or the Rust Meetup is coming back in April, and they're doing a bunch of this IoT stuff as well. So I don't know if how you're doing the Ditto FFI. It looks like there's a package in your Android Studio project.
Yes.
Okay.
This is in progress, but this is basically the file. I've been making changes to it where this is our Android stuff and here's our Java stuff. It's similar, but a little bit different, since like on macOS, I have to link the security layer. But we do have some C++ files that are sort of the source.
I'm scared of C++.
Yeah, I know. Same here. But yeah, it's like that's the interface, and then we take that and we run it through Swig to generate the
Swig.
Java.
Okay,
yeah.
You mentioned that.
Mm-hmm.
So Swig is your code generator that gets you to Java land.
Exactly.
Okay.
Cool. So here's our native stuff. So this really just runs the CMake build for us. And then, oh yeah, external native build. Where did I put it? I've been moving stuff around so much. I think it actually is in this FFI layer. Yeah. So we have, this is really just a custom Gradle task that generate or runs the Swig command. This isn't that helpful, but the Swig executable, which you can install through Homebrew, that just takes a couple of parameters like what's my package, where's my C code, and where am I going to dump stuff, and then it generates a whole bunch of FFI, and a bunch of this
stuff. So it generates
stuff.
some Kotlin files as well, a ditto handle wrapper.kt file up there.
So this is handwritten, but
okay.
All the stuff that's in pink is what's generated by Swig. So
Oh,
it
okay.
is Java that's
So a bunch
generated.
of Java. Okay,
Mhm.
cool.
But
So
this
you've already worked out the code generation for this stuff based on your Gradle script.
this was done before I joined, so I can't take credit. But I did
Well,
help.
hey man, that's pretty cool stuff.
It is cool stuff. And this attachment T is a type that's defined in Rust. So a lot of these things are straight out of our core. And this giant Ditto FFI is like all the functions that get exported. It's
That just
ginormous.
reminds me of the Objective-C garbage that Kotlin multi-platform cranks out. I'm
Yeah.
looking at these Objective-C interfaces from the. Yeah, I mean that's the only way to do it.
Yep.
I don't want to stop the demo because we're definitely in the weeds here with the JNI.
Yeah. So we should definitely connect more on this. I'm not that much of an expert on it, but I can operate the tools and get them to stop throwing errors.
Oh, I'm a big Rust fan now. It's my new favorite language.
Nice.
Yeah.
Wow.
Yeah, I'm impressed with Rust, especially because it uses LLVM and Swift borrowed a lot of stuff from it. However, for a big giant project such as ours, compile times definitely take a hit. But that's because it's applying a lot of smarts, like trying to guarantee you runtime behavior. All right, so come back. Let me relaunch that. Come on, I gotta have a second device.
So we're connecting to emulators.
No, this is a real device.
Oh wait, you're on Visor. Okay,
Yes.
cool.
There's very limited support for emulators. Like pretty much, I think they can only do a cloud connection at the moment.
That would be kind of weird to connect emulators to begin with, but I guess why not?
Yeah, we've been talking about adding a Android Studio plugin so that to be a proxy to expose some of the stuff so that you can do peer-to-peer with emulators, but we don't have it yet. Okay, so physical devices, I've got a Z Flip here. That's the dark one. No, Android. And then Pixel 3a, that's the light one. And this is our very simple cars app. And I apologize for the UI. This is another thing that our Android app needs to catch up on. But I'm gonna just hit add random car color, and you can see they're syncing really quickly with each other. I want to show you our presence viewer. So this is really cool because what this is showing, like I showed before in the slides, the blue connection is Bluetooth and the green connection is a LAN access point. So this is my home network. To do the Wi-Fi Direct, you actually have to opt into our Wi-Fi Direct feature, which I didn't do before this. It's like an experimental thing. And yeah, so I apologize.
Is that a permission that the user has to accept or something? Or
no? Well, yes, there are permissions the user has to accept, but I actually don't know if there's extra permission they have to accept for the Wi-Fi Direct.
Maybe location.
Maybe. But anyway, in our framework, it's an opt-in thing that I didn't enable for this. And I don't have a cloud connection. That's the purple one here. So this is literally one device to another. And you can see on the Z Flip, it can see the Pixel 3a, and the Pixel 3a can see the Z Flip Samsung thing. So let me go back. So one thing that's really cool, your application can actually control these transports directly. So if I want to turn off Bluetooth, I can do that. And in a second, we'll see Bluetooth turn off on the other device because we no longer have that connection. I think it's only going to take a second. Oh, there it goes. So I can turn that back on and I can turn off LAN. So you as an application developer can actually control these things yourself. Come back. Bluetooth should still be on. It does take a second for it to restart the transports.
So
Come on.
whenever you have multiple connection types, how does it decide which one to use?
So if LAN is available, like access point, it's going to use that one. That one's going to be the fastest and most reliable. Then I believe it would fall back to peer-to-peer Wi-Fi if that's available, because it's fastest. And then Bluetooth would be favored at a distance. So one of the things that makes this a little hard to demo is the fact that in order to save power, these transports aren't maintained 100% of the time. They'll kind of go off and come back on if there's no activity. But I do have both of them back now. One other thing I want to show you is if I go to the device level and disable Bluetooth, it also disconnects that. That one's a little faster because it's like still active as a transport within the framework, but it's just the availability of that sensor going away on the device that's just automatic. So I could be syncing data this whole time, and I'm kind of forcing it to switch from one scenario to another. But as my connection, gets further or closer, the framework itself might decide to use one or the other. I don't know if we'll multiplex it across these different connections in its current state, but that is something we've been looking at doing. But I can add stuff on this side, add stuff on that side, delete them all, poof.
Wow.
And yeah, I mean, it's amazing how fast this is. Now, if you're adding lots of data, like really big data, you're going to see the performance go down. But now I want to show you just how freaking amazing this is, because I just launched the app on 2 iOS devices. And yeah, the UI has gotten a lot more attention on the iOS devices, but you can see how that mesh, now that I've added 2 more devices, like data can go in almost any direction. So these 2 are iOS devices. Here's my 2 Android devices. The iOS devices have a peer-to-peer connection, or a peer-to-peer Wi-Fi connection between them, but we have LAN and Bluetooth between all of them. It looks like the Android estimate, based on the strength of the Bluetooth connection, is not as accurate as the iOS one. So I may need to do some work on that, because they are like 2 feet apart right now. But I swear, I just love looking at this thing. And actually this graph, you can resize it and like pull the things around. It's so much fun to play with.
So it looks like it's the Android to Android one that it's estimating the weird number of meters in.
Yep. So we saw some connections break just a second ago. Now all the devices are powered on right in front of me. You're seeing Visor show all of them. I think that's the fact that it realized, oh, hey, I can drop a couple of these connections because I can get to those other ones. So there's some optimizations where it will dynamically change the mesh. And I'm just fascinated at the fact that the guys who work on our core have figured all this stuff out. It's like so amazing.
This
So
is the sort of,
technically, if you were
go
to
ahead.
drop the one that is marked as me, the Samsung C Flip, is the other peers in the mesh should try to connect to each other.
Yeah. So let me go into airplane mode. Everything's off on this one, so it can't see anybody. On the iPad over here, dun, 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 it's still talking. Oh, I have to tap on the real device. So yeah, they're just happy talking to each other.
Wow.
Like, this is freaking magic. I mean, I know I'm not sending a lot of data in this case, but it's just so amazing how it'll just automatically connect. And you don't have to do anything as a developer. This just happens. And so any data, any one of these is putting into the store, because it's the same app, would just automatically be synced across. Guess I need to switch to somebody.
One thing I've noticed is that Rust, the Rust to C bridge is not nearly as painful as the Kotlin native bridge.
Really?
And so I'm finding that like Rust is a natural fit for some multi-platform stuff. But the issue is that it's very low level language. This is an example of Rust being used really effectively in like systems style programming. It's pretty cool.
Yeah. Yeah, and all of that magic is in that Rust core. The Java stuff and Kotlin that's on top of that is really just the API to give you something idiomatic, so you're not calling a C function.
Yeah, and that's where I'm curious about the code generation aspect. And that's it looks like you're using a different FFI than what I've seen.
Mm-hmm.
And the Android docs over here that were linked kind of give you like the hello world, the hello Rust, sorry, not hello world, hello Rust example.
Nice.
Yeah, that's the thing that I followed.
Yeah.
For my first rodeo. This
Cool.
actually just all came out recently.
Nice.
A lot of this Rust support's coming out, and I think on iOS they're also supporting Rust. I'm not sure on that.
I know there's a recent thing that came out where the Swift to C++ interop is getting better. I don't know too much about that. And actually our iOS stuff, we actually have an Objective-C library, and then our Swift library sits on top of that Objective-C.
I see.
So we go.
So the Objective-C is going, okay. Yeah. I would love to write Kotlin code everywhere, but that would definitely not go so well doing this sort of thing. And Rust is a really natural fit for it.
Yeah. I'm still learning Rust, and I'm not at the point where I've contributed to this core, but that is where all the magic is. And we even have like C++ and .NET libraries
being exported from Rust.
Yep.
Very cool.
Mm-hmm.
Yeah.
Or you could use our Rust SDK directly.
You have your own Rust SDK?
Yeah. So our doc site is fantastic.
I'm really interested in writing some Rust that I can consume on the Kotlin side and Android, at least for myself.
So there's not a lot of people using our Rust SDK. I've tried to like figure out how to call this because I barely know Rust, just playing around with it. And we do have API docs up here, but they probably need some TLC.
Rust is definitely not like the topic of our meetup, but this is the first time we've done some low-level Android in a while, I think. And I don't know if we've ever done a C++ talk in the history of Denver Droids.
I don't think so, not as far as I know.
Yeah.
I think it would be very interesting to talk about the Rust integration.
Yeah, Rust is a little bit, it's just way safer than C++. So that's the draw for me.
Yeah, one thing to watch out for when you're using our stuff, we move fast. We've been making lots of changes, so there are deprecated methods that are in there. Like start sync used to be how you would start this syncing stuff, regardless of who you're talking to. But now it's what is it? try start sync is the way you do it, because this will I think this handles a number of error cases. Oh, and by the way, that case where I was toggling Bluetooth on and on from the application level, all that is bundled in the transport config API. So in the transport config, you would set a new transport config that had Bluetooth disabled if you wanted to turn Bluetooth off, for example. But any of those different transports are configurable by you if you wanted to change things. And there's some help for dealing with permissions where you can refresh, like if your app hadn't been granted the right permissions, you do have to call this refresh to kind of tell Ditto, hey, you might actually be able to use local network or something. Cool. So I think that's all I've got.
So for example, do you find any limitations on the iOS side, or how is it working? I know that Android has very open APIs for many things, but on iOS, like how do you, or what are some of the technologies that are supported, like Wi-Fi Direct, Bluetooth, and do you find any roadblocks in there? Or has it been?
So I don't actually, or I haven't worked on the transports level much. I'm getting into that with our new .NET SDK, or adding Xamarin support to our .NET one, because the current .NET SDK is basically designed for .NET server apps, kind of like the Java SDK that I just worked on. So their only like real need would be a cloud connection, talk to the Ditto cloud, or maybe local LAN, but you'd never use Bluetooth on a server. So that's missing right now, and that'll need to be added in to support Xamarin with all the different transports on iOS or Android. So Bluetooth is notoriously hairy, regardless of which platform you're dealing with, mostly because I've heard from some developers that work at that layer, like sometimes even the Bluetooth specs have, issues in them, or it could be the implementation of Bluetooth. That's why we have like such a huge blog post. Like it might as well be a book. Let's see, here's the Japanese one. Getting started with core Bluetooth. Tim Oliver wrote this, and
Is this
look at this.
Bluetooth low energy or just normal Bluetooth?
I think this is using Bluetooth low energy, but I could be wrong. Like, it's insane how much stuff. And like at the end, like, you got to roll your own encryption. We've already handled that. There's lots of error cases where, you're dealing with very low level stuff that doesn't have a very good API around it. And actually, one of our clients said Apple has even admitted that their multi-peer connectivity framework is not as good as what Ditto has come up with, where it's just kind of seamless syncing. Like there's all this pairing and different UIs and stuff that gets in the way of just getting the work done. So honestly, like if you guys have some harebrained idea like the game that you want to make, I would encourage you to start tinkering, play around with Ditto, give me and us any and all feedback on it, like what you would want to see or trouble you have with following through with stuff, because at the core, it is amazing. We definitely have some work to do to make it really idiomatic and expose some of the power that's in that core. Like we have a V2 that we're just starting to design now that's going to expose more of those CRDT types. Because one key area of pain point is uh, when, let me switch to one of our
You do
things.
some awesome Kotlin stuff to expose to the Android folks, and that goes a long way.
Well, yeah, it's there, but we're trying to improve that layer. So one thing about the way this is implemented now with arrays is we have what's called an add wins map. This is a CRDT type where if you add something and I add something, we're just going to add both. But say you downloaded that data from a REST API and I downloaded that data from a REST API, and we add one, car 1, 2, and 3, and you add car 1, 2, and 3. What you're going to end up with is 2 copies of car 1, 2, and 3 in the array because of the behavior of arrays at the moment. And there's other types where you can have it dedupe those for you, like have a unique set or have a delete wins. And those types are not exposed through our SDKs yet. So we are working on design for that now, and there will be some new APIs coming out. And V2, we're probably going to touch up a lot of things and throw away some of that deprecated stuff. So that's one reason why I'm really interested in feedback, because we have a chance where we can make some breaking changes and come up with a really nice API like what you'd want to see. But CRDT types, I mean, that's basically a whole another talk. But they're fascinating in the fact that you can have true peer-to-peer like conflict resolution encoded in the data, as opposed to having to have some master in the cloud. Like Google Docs right now, you cannot sync peer-to-peer even though you can work offline, and it's only because the tie-breaking logic has to live on the server, a trusted peer essentially. And you don't need that for every application. You only need that for like sensitive things. And so we've Ditto's been designed from the ground up to support this peer-to-peer syncing. And some of those types that are going to be exposed to the SDK soon are going to give you more power to craft the right data model for your app.
That is absolutely amazing. Like, I want to download right away the chat app. Like, there's all sort of situations where having like the shared app for chatting. Now, is that chat intended to be, or is that being just developer only, or have you guys actually published on the Play Store and App Store?
It's published. So here's a link to our demo apps. You can download the chat app. The sample flight bag app is only iOS. The inventory one is the one I showed you, Eric, where you can just, it has kind of like a fake shopping cart where you can just hit plus or minus on the items and you can see it increment and decrement. And when I demoed this to my son, he had, what was it? He had Bluetooth off, and I launched the app and I had Wi-Fi off, and I didn't realize he had Bluetooth off. And I started like messing with the inventory, and it was like immediately changing on his phone. But then when he showed me he had Bluetooth off, I was confused and didn't know how this was even working. Well, it turns out we had a mesh with my iPad here, and my iPad with this app in the background was the common peer for us that all this data was syncing through. And it's crazy how well this works. Oh yeah, and the presence viewer, which is just fun to play with and like drag these little nodes around. But yeah, I obviously need to work on that distance estimate for Android Bluetooth.
So my last question, I'm curious about the background capabilities of the syncing. Is that something the developer working with the SDK has to implement, or it does already some of the legwork on how to stay synchronized in the background?
So no, you, the developer, do not need to worry about that. That's automatic out of the Ditto SDK. However, I have heard that the background syncing capabilities on Android aren't working as well as they used to. I haven't really put that through the paces, but that's something we'll be looking at pretty closely. But it definitely syncs in the background, even if the app is not open. The question is like, why isn't it staying alive as long as we expect it to? Because we want to put that control in your hands as a developer. So if you want to optimize for battery life, you could do that. We do have some battery optimizations already baked in, but that's like where it sets up a connection and tears it down for a little while. But if you want to like just shut it all off, from the background, from a push, I think there are APIs missing for that. If they were in the foreground, the user could certainly tap something and you could turn off Bluetooth or LAN or just stop sync altogether to save some battery. So right now, I guess foreground only for doing any tweaks to what's active. But yeah, there's one report that we need to look into where these connections are being maintained like indefinitely or getting stood back up when you come near a device without relaunching or re-foregrounding the app. Still need to figure out whether it's like the app being killed on that device or what.
Yeah, I know that the newer Android OS versions have lots of restrictions on what's running on the background. And you're probably hitting some of those limitations where sometimes it will give you just a few seconds after you exit the app to either finish your operations or make it a foreground service, for example, so that it will show a notification on the top that saying that you're synchronizing and the app's still doing work, and then it will let you continue doing some operations. But otherwise, you're going to have to use something like the work manager to just have scheduling events like every now and then, or put some rules on when to relaunch the syncing. But I love the technology. I would love to go through the SDK. The first thing I'm gonna download is the chat. Like sometimes I've been in events where you're just in the middle of nowhere, sometimes in the middle of the desert.
Good
And it would be
peer-to-peer chat
amazing.
with no Wi-Fi, no network.
Right.
Cool.
No cellular, no Wi-Fi, no anything. I mean, just peer-to-peer.
Yep.
Like this will be amazing also for emergency services. Like,
yeah,
I cannot wait to tinker with it. Like even for emergency services or just general chatting or sharing files. I mean, it's just amazing all you can do. So kudos.
Yep.
Like it's an amazing technology, and thank you, Ben, for presenting tonight.
Sure.
I'm eager to build and sometime building.
Yeah. So download the sample apps, check out our sample apps on GitHub, check out the docs. Let me know if you have any questions or feedback on any or all of the above.
So
we're just
for
trying to
now,
make this great.
does anybody trying out the SDK has to get a API key or anything?
Yes. So, well, yes and no. The key thing, let me show you in the Ditto portal. So the first thing you really should do, like, which, do we say it in here? Yeah. So on our getting started for Android, there's the basics for like adding the dependency and the permissions. Here's all the permissions that we need, so you can copy and paste into your Android manifest. And then here's the code to just bootstrap Ditto. So online playground is the key, like API for starting it up. And you need an app ID. Now, how you get an app ID is you go to our portal which I think, yeah, get started up at the top will take you to the portal. So this is going to the Ditto cloud. And yeah, so you'll want to create an account, and when it sees me coming from Ditto, I can sign in with SSO, and it lands me on a page where you can create an app. So you would create a new app. So I had created a Denver Droids app, and this is what its app URL is going to be. And this is the app ID that you'll want. So this is what you copy and paste into this call. Now what Online Playground is going to do is it's going to talk to the Ditto cloud and validate that that's a real app, download a certificate, and from that point on, you don't actually need to be talking to the cloud, but it needs to do that handshake to get the license. We do have this thing like a license token. This is actually not going to be generated automatically pretty soon here. Like these do expire. But if you have a purely offline use case where you don't want to have to handshake with the cloud, there will be a way in the near future where you can obtain one of these license tokens, like by pushing a button. I don't know what the expiration threshold is going to be on those, but like this one that I have for this app I just created is going to expire in 2 weeks. I think that we're planning on having this feature live by then, because all these offline only license tokens are going to expire.
Could write a Kotlin multi-platform app where you just do the expect actual pattern with this ID just for fun. That doesn't do anything, but just loads up a little Kotlin multi-platform deal. I would have to see the iOS implementation too.
Cool. Yeah, so that's the basics to get Ditto going, and then you would start adding data or querying for data on top of that. There's some other things in here about dealing with permissions and if permissions change. And then down here, you can jump straight to our Kotlin docs to see all the different APIs and what can be done all over the place.
Wow, I love it. I love how every single thing is documented with an explanation. And
yeah, the docs are surprisingly good. We actually, I guess the docs site doesn't support dark mode, but we added dark mode to like our main site and some other things. But because we know developers are our main customers, docs are where like most people go. It's like, I don't know, half or a quarter of everybody that lands on the web page goes straight to the docs. So yeah, that's why I'm talking to you guys as developers, because I want to help you guys get whatever your ideas are up and working and flesh out the ideas. Like the overall business model is that you should be able to, just like any other cloud service, be able to try it out, play with it all you want for, proof of concept stuff and very tiny apps. And really only once you have an app that's taking off and demanding a lot of resources would there be payment involved. But yeah, like I said, a lot's changing, like with that license token expiring at the end of this month. The Online Playground is the best way to like just get an app working, not worry about permissions. You do just have to register and get that app ID GUID and plunk it in there, and you're up and running. And note that 2 apps need to have the same app ID given to this API in order to sync. If you had Ditto in 2 apps installed on the device, they would only sync with other apps that have that same app ID, because they'd all share like the same root certificate. So even if the 2 apps are in your same developer accounts, only the ones for the same app ID will talk to each other.
so if I understood correctly, for example, if you had your app, let's say on Android, and you were to offline share the APK with another user of the app, that user will have to be connected online at least once to download the certificate and authenticate.
I think so.
Okay.
I think that's how it works with this new online playground mode. For a lot of applications, connecting to the cloud isn't a problem, but once it's done the handshake, then it should be able to talk with other devices, even if it doesn't have a cloud connection.
All right.
It's really about establishing that certificate, I believe.
Well, thank you, Ben. I really appreciate it. I love
Sure.
the technology. Does anyone else have any questions?
I don't have a question, but I have a comment. I really like Ben's haircut.
Hey, Alexi.
Hey guys, sorry I just had to join late today, but
Where are you located?
I'm located in Colorado, in Aurora.
Okay. I noticed the name, and I was wondering if Denver Droids was lucky enough to get somebody from elsewhere that came for this one talk to our meetup. It's happened a couple of times, but not today. You're in Aurora.
Yeah.
I think this has been a really awesome one as far as Denver Droids meetups go. Pretty good content. I do think I will play with this.
Nice.
Like every time I see this, my mind goes crazy on all the stuff that I want to build.
Mm-hmm.
It's like when you get like that new tool and you just want to apply it for everything.
Yeah. So initially when I heard about this, I was only thinking of the healthcare use cases because that's where I used to work. And I'm like, we're never going to sync, very sensitive medical data peer to peer. But as soon as I started thinking outside of that limitation, I was like, oh my gosh, I would love to just be able to send files peer to peer, like even like iCloud between my Mac and my phone.
Right.
It still has to go up through the cloud. And I'm just like, why?
Right.
On iOS, I think the AirDrop is got to be
Yeah.
doing something similar under the hood with accessing Bluetooth and Wi-Fi and choosing whichever one is or something.
Yeah, so AirDrop is truly peer-to-peer, but I mean, they both have to be online. You have to see each other. Sometimes
Right.
permissions gets in the way. That's the annoying thing about that. I was more referring to like iCloud, where like if I copy and paste something, it has to go up to the cloud and come back down. So there's a noticeable
Yeah,
delay.
but this
And
is still better though than in a way that we can connect Android and iOS are now being able to do this. So it's not
Yes.
closed into that ecosystem or anything.
Mhm.
There's a lot of opportunities for this stuff.
Yeah.
I'm thinking
super
oil
curious.
and gas as well, like, in remote areas where they're trying to send things or I don't know.
And I'm super curious whether this will run if I were to, for example, put Android on a Pi, on a Raspberry Pi, and then like try to run an app with Ditto, like for example, file syncing or just even for IoT stuff, like
So
having them share what are the some of the data on within the mesh or the network. So I'm curious of all the implementations. I would love to see this running on a Pi.
So I know it works on a Pi, and I don't think we have a guide on it. I mean, there's the getting started for the C++ SDK, and we do have our API reference, but we don't have like a full-on explanation of how to get it up and running on a Pi, from what I know. But yeah, comb through the docs, reach out if you have questions. But I know it does work on a Pi. So if you wanted to use a Pi as your shared server between multiple mobile devices or just do IoT stuff, Ditto's ready for it.
That is amazing. Amazing.